So part 3 asks us to find these algebraically and graphically. I'm not too concerned about graphically because I think a lot of you could just log on to Desmos or use your graphing calculator, plug things in, and find what you need. I'm going to focus on algebraically right here, and what I'm going to do is I'm going to show you one possible way to do it. There is obviously more than one right way. So as I take a look at part A, if I wanted to solve this algebraically, I'm going to take note of the fact that in the second equation, everywhere I see an x, I can replace with 3y minus 5. So if I then plug that in right there, I now have the following. I now have 3y minus 5 plus my y is equal to 3. If I clean this up a little bit, 3y and y will make 4y. Minus 5 is equal to 3. Add 5 to the other side. I'm running out of room. You get 4y is equal to 8, which means y is equal to 2 when you divide by 4. Now that I know what y is, I'm going to take that 2, I'm going to plug it back into this equation in order to find that x is equal to 3 times 2 minus 5, or 6 minus 5, which is 1. Which means I get the ordered pair 1, 2. The solution to these problems should be an ordered pair. You're not just finding an x, you're not just finding a y, but you're finding the pair that mark the point where these two lines cross. So I have made a substitution step, putting 3y minus 5 in for x, and then doing my algebra found y. Once I found y, plugged it in to solve for x. Now if we go over to b, I don't have any of my variables isolated. So you might remember this isn't going to be substitution, it's going to be a different name that you learned last year, and I'm going to use a strategy called elimination. And the idea behind elimination is this. If you look at one of your letters, in this case my y's, you'll notice I have the same number or coefficient in front. They're both essentially a 1. And I've got different signs. I've got a plus 1 and a minus 1. And what that means is if I were to add these two equations together, 16x plus 2x becomes an 18x. Minus 1y plus 1y cancels to make a 0. And then negative 4 plus 13 gives me a positive 9. I divide both sides by 18, and I now have that x is equal to 1/2. This is called elimination because we have eliminated one of our variables, and one part of it is now gone. Now that I know x is 1/2, I can go back up to one of my equations. It doesn't matter which one, I'm just going to choose the second one. And I'm going to have 2 plug in the 1/2 for x, plus y is equal to 13. So 2 times 1/2 is a 1, which I'm going to subtract from both sides. And I now know that y is 12. And I get a final ordered pair of 1/2, 12. So far, so good. And then we come along to part C. And this is going to be a little messy just because I'm running out of room, and that's okay. And what happens in C is now we've got a line and a parabola. So in the background, I want you to remember as a little thought bubble, I want you to think about the picture. You could have a line and a parabola miss each other and have 0 solutions. You could have a parabola and a line hit at exactly 1 point. Or you could have that parabola and that line cross in such a way that they get 2 solutions. So it would not be unreasonable for us to have 0, 1, or 2 solutions. So if I take that value for C, and I look at this problem, y equals, I'm going to jump over and use the substitution step we did in part A. So I can say that x squared plus 5x plus 8 is equal to x plus 5. I can merely set the two sides equal to each other. my preference is going to be to keep the x squared positive. It always will be. So if I subtract my x and subtract my 5, I now have x squared plus 4x plus 3 is equal to 0. This is helpful because if I want to use any of my strategies, factoring or quadratic formula, I must be equal to 0. I cannot stress that enough. If you are going to solve a quadratic, you must be equal to 0. So at this point, I can jump straight to factoring, in which case I know that this is going to factor into x plus 3, x plus 1. Now, if you're still wanting to make the box or make the diamond, that's fine. But on these simple ones, try to see if you can just find the pattern. You're looking for two numbers that multiply to 3 and add to 4. Well, only numbers that multiply to 3 are 1 and 3, and sure enough, 1 plus 3 is 4, and that checks out. Now the thing though is we weren't asked to factor, we were asked to find the solutions of the system. So I need to keep going. I now know that x plus 3 is equal to 0, and x plus 1 is equal to 0, which means I get x values of -3 and -1. And just like the previous problems, if I know my x values, I now need to take them, plug them back in order to solve for y. Also, take note, we got two solutions, which means I know my picture is closer to something like this than it is these previous examples. So I need to take both the -3 and -1 and plug them back into one of my equations. It doesn't matter which one you want to use, but I think it goes without saying that one of these is way easier than the other. So I'm going to do this one, because if all I have to do is add 5, why not? So I add 5 to this one, and I get -3, +2. I add 5 to this one, and I get -1, +4. And those would be the two solutions for part C.